Right now, as you sit here reading this, trillions upon trillions of invisible particles are moving through your body every second. Light crosses the room and enters your eyes. Electrons flow through wires around you. Atoms vibrate quietly inside the walls, the air, your skin, your bones. Everything feels solid, stable, and heavy. Objects are harder to move. Large planets possess stronger gravity. Stars collapse under their own weight because they contain enormous amounts of mass. And yet, for a long time, physicists could not answer one deceptively simple question. Why does anything have mass at all? Not what mass does, not how to measure it, but why it exists in the first place. Because when scientists began uncovering the deeper structure beneath matter during the 20th century, they encountered a disturbing problem hidden inside the equations of particle physics. The more fundamental the laws became, the less natural mass itself appeared. In fact, according to some of the most elegant versions of the equations describing reality, many particles should not possess mass at all. They should move forever at the speed of light, which means you should not exist. Atoms should never properly form. Chemistry should fail completely. Stars, planets, oceans, and biological organisms would become impossible because the particles composing them would behave entirely differently. Reality itself depends on mass existing. And yet, deep inside the equations governing the universe, mass initially looked almost unnatural, like something awkwardly inserted into the mathematics afterward, rather than emerging naturally from it. This problem became one of the greatest mysteries in physics, and the solution would eventually reveal something extraordinary. An invisible field stretches throughout the entire universe, surrounding every galaxy, every planet, every atom, and every human being constantly. You are immersed inside it right now. Every particle in your body moves through it continuously. Without this field, matter as humans know, it could not exist. This invisible structure became known as the Higgs field. And once physicists understood what it implied, reality itself began looking stranger than ever before. To understand why the Higgs field matters so deeply, you first need to understand something unsettling about the universe itself. At fundamental scales, reality behaves far less like ordinary solid matter and far more like a hidden ocean of quantum fields, fluctuating beneath everything humans directly experience. Modern particle physics no longer describes electrons and quarks as tiny independent balls floating through empty space. Instead, particles are excitations of invisible fields permeating all of existence. The electron field exists everywhere. The quark fields exist everywhere. The electromagnetic field exists everywhere. Empty space itself is filled with hidden structure, and under ordinary circumstances, many of these fields behave beautifully inside the equations. Symmetries appear, forces unify elegantly. The mathematics becomes astonishingly simple and powerful. But there was a problem. According to these symmetrical equations, certain force-carrying particles should remain massless. For photons, this works perfectly. Light travels at the speed of light precisely because photons possess no rest mass. Electromagnetism extends infinitely across space because the photon is massless. Everything fits beautifully. But the weak nuclear force behaved differently. The weak force governs radioactive decay and certain nuclear interactions deep inside stars. Without it, the sun could not shine properly. Nuclear fusion would behave differently. The chemistry required for life might never emerge. Yet, unlike electromagnetism, the weak force operates only across incredibly tiny distances inside atoms. Why? Because its force-carrying particles, the W and Z bosons, possess enormous mass. And this created a mathematical disaster. Simply inserting mass directly into the equations broke the elegant symmetries, making the theory work correctly. The equations lost consistency. Predictions failed. Particle interactions became mathematically unstable. It seemed impossible to preserve both symmetry and mass simultaneously. For years, physicists struggled with this contradiction. Then, during the 1960s, several scientists independently developed an extraordinary idea. What if empty space itself was not truly empty? Not merely because of quantum fluctuations or hidden fields already discussed in modern physics, but because one particular field possessed a strange property unlike the others. Most fields settle naturally into zero when no particles excite them. But this new field would behave differently. Even in a perfect vacuum, the field would maintain a non-zero value everywhere. The vacuum itself would become filled with invisible background structure. Particles moving through space would constantly interact with this field. Some particles would couple strongly to it and behave as though they possessed greater inertia. Others would interact weakly and remain lighter. Photons would not interact with it at all, remaining massless. Mass would not be an intrinsic property carried permanently inside particles themselves. It would emerge from interaction. This idea changed the meaning of matter completely. Because suddenly, mass stopped looking like a built-in characteristic of particles and started looking more like resistance, emerging from invisible interactions with the vacuum itself. A famous analogy often compares this to moving through a crowded room. Imagine an important celebrity entering a dense crowd. People gather around them, slowing their movement through the room. Another person passes through mostly unnoticed and moves more freely. In the Higgs field analogy, particles interacting strongly with the field acquire greater effective mass, while particles interacting weakly remain lighter. Now, this analogy is imperfect scientifically, but emotionally it captures something important. The vacuum itself resists certain particles. Mass emerges from hidden interaction, with invisible structure permeating all of space. And perhaps the strangest implication is this. Without the Higgs field, the universe would become almost unrecognizable. Electrons would move at light speed. Atoms would not stabilize normally. Chemistry would collapse. Stars would behave differently. Complex matter would likely never form at all. Human beings exist partly because empty space itself possesses hidden structure, interacting with particles continuously. The vacuum shapes reality, and for decades, physicists searched desperately for proof this field actually existed. Because elegant mathematics alone is not enough in science, the universe itself must confirm the theory experimentally. According to the equations, the Higgs field should produce a corresponding particle, an excitation of the field itself, just as photons arise from the electromagnetic field. This particle became known as the Higgs boson. Finding it became one of the greatest scientific quests in modern history. The challenge was enormous because the Higgs boson is unstable and incredibly difficult to produce. Creating one required enormous energies, similar to conditions existing fractions of a second after the Big Bang. For decades, no machine powerful enough existed. Then humanity built the Large Hadron Collider. Deep beneath the border between France and Switzerland, scientists constructed the most powerful particle accelerator ever created. Protons accelerated to near light speed around a massive underground ring before colliding with unimaginable energy. Inside those collisions, conditions briefly recreated tiny echoes of the early universe itself. And on the 4th of July 2012, physicists announced something historic. Evidence strongly confirmed the existence of the Higgs boson. Humanity had discovered the field hidden inside empty space itself. The announcement represented far more than merely discovering another particle. It confirmed something profound about reality. The vacuum is not passive emptiness. It possesses hidden structure, determining why matter exists in the form humans experience at all. Mass arises partly because particles move through invisible fields permeating the universe continuously. And once this realization truly settles into the mind, the world begins feeling very different. Because solid objects stop seeming entirely self-contained. Matter itself depends on interaction with deeper hidden structures underneath reality. Every atom inside your body gains its properties, partly through invisible quantum fields, extending throughout all of space. You are immersed inside the Higgs field every second of your life. Everything is. And without it, the universe would likely remain filled only with formless radiation racing endlessly through darkness, incapable of building stars, planets, or living beings at all. The deeper physicists looked into reality during the 20th century, the stranger the universe became. At first, discovering atoms already felt revolutionary. Matter, once believed continuous and solid, turned out to consist mostly of empty space with tiny nuclei surrounded by electrons. Then the nucleus itself shattered into smaller particles. Protons and neutrons contained quarks. Forces became mediated by exchange particles. Reality transformed from solid objects into quantum interactions governed by invisible fields beneath ordinary experience. And with every layer uncovered, the equations became more elegant. This elegance mattered deeply to physicists, because nature repeatedly seemed to favor mathematical symmetry underneath complexity. Different forces that appeared unrelated at ordinary scales began revealing hidden unity at deeper levels. Electricity and magnetism merged into electromagnetism. Space and time merged into spacetime. Particles and waves blurred together into quantum behavior. The universe increasingly resembled a hidden mathematical structure beneath visible reality. But then mass ruined everything. Because without mass, the equations looked beautiful. Particles traveling at light speed fit naturally into the symmetries of quantum field theory. The mathematics remained clean, balanced, and internally consistent. But the moment physicists tried inserting massive particles directly into the equations governing the weak nuclear force, the entire structure began collapsing mathematically. Predictions exploded into infinities. Symmetries broke. Interactions stopped behaving properly. The equations no longer described a stable universe. This created a crisis in particle physics, because the weak force obviously exists in reality. Radioactive decay happens, nuclear fusion powers stars. Neutrinos interact through weak processes constantly. And experiments confirmed that the W and Z bosons, carrying the weak force, were incredibly massive compared to photons. So nature clearly allowed massive force particles somehow, but the equations seemed to forbid them. For years, physicists stood trapped between mathematical beauty and experimental reality, and the solution that eventually emerged was one of the strangest ideas in modern science. Instead of giving particles mass directly, perhaps mass could emerge indirectly through interaction with the vacuum itself. This distinction sounds subtle emotionally, but it changes the meaning of reality completely. Because under the Higgs mechanism, particles are not fundamentally heavy by themselves. Instead, the vacuum surrounding them contains hidden structure interacting continuously with certain particles as they move through space. Mass becomes relational, not intrinsic. And to understand why this works, it helps to think about symmetry. Symmetry in physics does not merely mean visual balance. It refers to transformations that leave the laws of nature unchanged. Rotate certain systems, shift coordinates, or alter fields mathematically, and the equations remain identical. These symmetries are incredibly important because they generate conservation laws and stabilize physical interactions. The equations governing electromagnetism possess elegant gauge symmetry. This symmetry naturally produces a massless photon. And because the photon remains massless, electromagnetic forces extend infinitely through space. Light can travel across billions of light years because nothing cuts the interaction short. But the weak force behaves differently. It operates only across subatomic distances. Something must suppress it, and the Higgs field provided the answer. Instead of breaking symmetry explicitly by inserting masses directly into the equations, the Higgs field breaks symmetry spontaneously. This idea is emotionally strange because the underlying laws remain symmetrical while the vacuum state itself does not. Imagine balancing a pencil perfectly upright on its tip. The laws governing the pencil are rotationally symmetrical because no direction is preferred initially. But once the pencil falls, symmetry disappears because the pencil now points somewhere specific. The underlying laws remain symmetrical. The chosen state does not. The Higgs field behaves similarly. At extremely high energies, such as conditions existing shortly after the Big Bang, the electroweak force may have existed as a unified symmetrical interaction. Particles remained effectively massless. The Higgs field sat in a higher energy symmetrical state. But as the universe cooled, the field underwent a phase transition. The vacuum itself changed state. The Higgs field settled into a non-zero value permeating all of space permanently. Symmetry broke spontaneously. Particles interacting with the field acquired mass through this interaction. And suddenly, the universe transformed. Before this transition, reality may have looked radically different from the universe humans know today. Particles raced through space at light speed. Stable atoms could not properly form. Matter behaved more like radiation than structured material existence. Then the Higgs field condensed into the vacuum, and the universe gained mass. This moment may have been one of the most important transitions in cosmic history, because without it, stars, planets, chemistry, and biology likely never emerge. Complex structures require particles moving slowly enough to form stable bound systems. Electrons need mass to orbit atomic nuclei properly. Quarks need mass relationships, allowing protons and neutrons to stabilize. The Higgs field helped transform the universe from a chaotic sea of radiation into a cosmos capable of building structure. And perhaps the strangest part is that this field still surrounds everything constantly. The Higgs field did not disappear after the early universe. It remains everywhere. Every atom in your body interacts with it continuously. Every quark inside protons interacts with it. Every electron surrounding nuclei interacts with it. Even now, at this exact moment, invisible quantum structure permeating all of space helps determine why matter behaves the way it does. The vacuum itself shapes existence, and this realization quietly changes how you see ordinary objects forever. A table stops being merely wood. Your body stops being merely flesh. Matter itself becomes dynamic interaction suspended inside hidden quantum structure, and the Higgs field is only part of that hidden structure. Modern physics increasingly suggests reality is built from layers of invisible fields woven throughout the vacuum simultaneously. The electromagnetic field governs light. Gluon fields bind quarks together inside nuclei. Electron fields permeate space everywhere. Neutrino fields drift ghost-like through the cosmos. And underneath them, all sits the Higgs field, quietly giving mass to fundamental particles through constant interaction. Reality resembles an invisible ocean beneath ordinary perception. Particles become ripples, moving through deeper structure. And then there is another astonishing detail. Most of the mass inside ordinary matter does not actually come directly from the Higgs field alone. This surprises many people emotionally, because popular explanations often imply the Higgs field creates all mass. But the situation is more subtle. The Higgs field gives fundamental particles like quarks and electrons their intrinsic masses. Yet most of the mass inside protons and neutrons arises from the energy of gluon interactions and quantum motion inside them. Einstein's equation E=mc² appears again here. Energy itself contributes mass. Inside protons, quarks move violently while gluon fields bind them together through the strong nuclear force. The energy of these interactions produces most of the proton's total mass, which means your body's mass arises partly from invisible quantum interactions and energy trapped inside atomic nuclei. Matter becomes even stranger. Solid objects are not fundamentally solid little chunks of stuff. They are organized energy patterns stabilized through quantum fields. And perhaps this is why modern physics feels emotionally unsettling sometimes. Human intuition evolved around surfaces and appearances. Rocks feel solid, bodies feel stable, space feels empty. But deeper investigation repeatedly reveals hidden activity beneath those appearances. Atoms are mostly empty space. Particles emerge from fields. Mass arises from interaction. The vacuum itself contains structure. Reality is not what it first appears to be. And somewhere beneath everything humans experience daily, the Higgs field continues stretching invisibly throughout the cosmos, quietly shaping the existence of matter itself. There is something deeply unsettling about realizing that the universe humans experience directly is not the universe that actually exists underneath. Reality feels solid. Tables resist your hands. Floors support your weight. Your body occupies space consistently. Matter appears stable and self-contained. Even empty air feels mostly passive and harmless. But modern physics paints a radically different picture. Beneath ordinary perception lies an invisible ocean of quantum fields stretching throughout all of existence simultaneously. Every particle humans observe emerges from these fields. Every force arises from interactions between them. And hidden among them, surrounding everything constantly, sits the Higgs field quietly shaping the structure of matter itself. You are immersed inside it right now. Not metaphorically, literally. The Higgs field extends through every galaxy, every planet, every atom, every cell in your body. It existed before Earth formed. It filled the universe before stars existed. Long after humanity disappears, the field may continue stretching silently across cosmic emptiness, and yet human beings cannot feel it directly at all. This disconnect between reality and perception is one of the strangest consequences of modern physics. The deepest layers of existence become increasingly invisible, precisely because they are everywhere constantly. Humans notice changes more easily than backgrounds. Fish rarely think about water. Likewise, people never feel the Higgs field because it surrounds them continuously. But without it, nothing familiar could exist. To understand why, imagine a universe without the Higgs field entirely. At first, this may not sound dramatic emotionally. After all, invisible quantum fields already feel abstract and distant from ordinary life. But removing the Higgs field changes reality so profoundly that the resulting universe becomes almost unrecognizable. Electrons would become massless. Quarks would become massless. The W and Z bosons, carrying the weak force, would become massless too. And immediately, the structure of matter begins collapsing. Electrons normally orbit atomic nuclei because their mass allows stable quantum configurations to form. Without mass, electrons would move perpetually at light speed. Atoms, as humans know them, could not organize properly. Chemistry would fail almost completely because chemical bonding depends on stable electron behavior. No chemistry means no molecules. No molecules means no biology. No biology means no living organisms. Stars would behave differently too. Nuclear processes deep inside stellar cores depend delicately on particle masses and weak interactions. Fusion pathways change. The balance between radiation and matter changes. The entire evolutionary history of the cosmos diverges into something alien. The Higgs field helped transform the universe from featureless radiation into structured existence. And perhaps the strangest part is that this transformation occurred naturally during the early universe itself. Shortly after the Big Bang, temperatures were so extreme that the Higgs field behaved differently. The electroweak force remained unified. Particles effectively lacked the masses they possess today. The cosmos existed in a radically different state from the modern universe. Then came symmetry breaking. As expansion cooled the universe, the Higgs field settled into its lower energy configuration, permeating space permanently. The vacuum itself changed character. Particles interacting with the field acquired mass. Reality underwent a phase transition. This moment was not like a normal explosion or collision humans intuitively imagine. It resembled water freezing into ice or steam condensing into liquid. The underlying laws remained the same, but the state of the vacuum changed fundamentally. And once it changed, the universe could begin building complexity. Matter slowed down enough to form stable structures. Quarks combined into protons and neutrons. Electrons orbited nuclei. Atoms formed. Eventually stars ignited. Galaxies evolved. Planets emerged. Life appeared. Human beings owe their existence partly to the Higgs field condensing into the vacuum billions of years ago. And emotionally, this changes the meaning of empty space completely. The vacuum is not passive emptiness underneath matter. It actively determines the properties of matter itself. Every atom inside your body behaves the way it does, partly because invisible fields permeating space continuously interact with its particles. The universe becomes relational rather than object-based. Matter is not independent from the vacuum surrounding it. The two are inseparable, and modern particle physics keeps revealing this pattern repeatedly. The electromagnetic field governs photons and light. The gluon field binds quarks together inside nuclei. The Higgs field generates mass interactions. Neutrino fields drift almost invisibly through the cosmos. Reality begins looking less like separate things floating through emptiness, and more like overlapping invisible structures, interacting continuously. This picture becomes even stranger once quantum mechanics enters fully. Because quantum fields do not behave like ordinary classical fields, they fluctuate constantly. Even in complete darkness, even inside a perfect vacuum, the fields cannot remain perfectly still. Quantum uncertainty forbids total stillness. The vacuum itself becomes restless. Tiny fluctuations ripple continuously beneath apparent emptiness, and this means the Higgs field itself fluctuates too. Even the field responsible for mass participates in quantum uncertainty. The vacuum never truly settles into perfect stillness anywhere in the universe. Reality hums invisibly underneath existence. And perhaps nowhere did humanity confront this hidden structure more dramatically than inside the Large Hadron Collider. The LHC was built partly to answer one enormous question: does the Higgs field actually exist physically? For decades, the Higgs mechanism explained particle masses beautifully mathematically. but physics requires experiment. Elegant equations alone are not enough. Nature itself must confirm them. The challenge was immense because detecting the Higgs boson required recreating conditions similar to those existing fractions of a second after the Big Bang. Protons had to accelerate around a 27-kilometer underground ring at energies never previously achieved by humanity. When the particles collided, enormous energy densities briefly formed, allowing rare quantum processes to occur. And occasionally, for unimaginably tiny fractions of a second, Higgs bosons appeared. These particles decayed almost instantly into other particles, but their decay patterns left recognizable signatures inside detectors. Physicists analyzed colossal amounts of collision data, searching for statistical excesses matching theoretical predictions. Then, in 2012, the signal emerged clearly enough to announce publicly. Humanity had discovered evidence for the Higgs boson. The invisible field hidden throughout reality was real, and this discovery mattered far beyond particle physics itself, because it confirmed something profound about existence. The vacuum possesses hidden structure, affecting every piece of matter in the universe continuously. Mass is not merely a built-in property of particles. It emerges through interaction with invisible fields, permeating spacetime itself. And once again, ordinary human intuition fails completely. The world feels solid and obvious. But beneath appearances lies a hidden quantum ocean shaping reality constantly without ever revealing itself directly to human senses. You are immersed inside that hidden structure right now. Everything is. Human beings instinctively think of mass as substance. A rock feels heavy because it contains more stuff. A planet possesses enormous gravity because it contains vast amounts of matter. Your own body feels solid because atoms appear densely packed together into flesh and bone. Mass seems simple emotionally, almost obvious, but modern physics quietly destroys this intuition completely. Because when scientists finally looked deep enough inside matter itself, they discovered something astonishing. Most of the mass in your body does not actually come from particles possessing intrinsic mass. In fact, most of it comes from energy. Invisible quantum energy trapped inside atomic nuclei. This realization is one of the strangest consequences of particle physics because it changes what matter fundamentally is. Human beings are not mostly built from tiny solid particles carrying permanent weight internally. Instead, much of ordinary mass emerges dynamically from violent quantum interactions, occurring constantly inside every proton and neutron. Reality becomes process rather than substance. To understand why, imagine zooming inward into a single atom. At first, atoms already look mostly empty. Tiny nuclei sit surrounded by diffuse electron clouds, occupying enormous relative volumes. If an atom were enlarged to the size of a football stadium, the nucleus itself would be smaller than a grain of sand near the center, while electrons would exist as probability distributions spread far outward. Matter already stops looking solid at atomic scales. But the deeper surprise comes inside the nucleus itself. Protons and neutrons were once believed fundamental. Then, experiments during the 20th century revealed they contain smaller particles called quarks, bound together by the strong nuclear force. This force is carried by particles called gluons, which constantly move between quarks inside the nucleus, and the interior becomes unimaginably violent. Quarks inside protons move at relativistic speeds. Gluon fields fluctuate continuously. Virtual particles emerge and disappear constantly. The interior of a proton resembles less a tiny solid object and more a storm of quantum activity confined inside an incredibly tiny region. And this storm contains enormous energy. Einstein's equation E equals mc squared revealed that energy and mass are interchangeable. Energy contributes inertia and gravity the same way ordinary mass does, which means the violent energy trapped inside protons contributes directly to the mass of matter. This leads to an astonishing conclusion. The Higgs field gives quarks their intrinsic masses, but those quark masses account for only a small fraction of the total mass inside protons and neutrons. Most of the proton's mass comes from the energy of the strong force itself. The energy of gluons, the kinetic energy of confined quarks, quantum fluctuations trapped inside the nucleus. Your body's mass arises largely from invisible energy imprisoned inside atomic structure. And emotionally, This changes the meaning of matter completely. Because solid objects stop being little collections of tiny solid pieces, matter becomes stabilized energy patterns emerging from deeper quantum fields underneath reality. The universe begins looking less like machinery built from objects, and more like organized vibration held together by invisible forces. And the strong nuclear force responsible for this is extraordinary. Unlike electromagnetism, which weakens with distance, the strong force behaves almost oppositely. Quarks become more tightly bound as separation increases. Trying to pull quarks apart only injects more energy into the gluon field until entirely new particles emerge instead. This phenomenon is called confinement. Individual quarks never appear freely under ordinary conditions because the strong interaction prevents isolation. The force becomes so powerful at larger separations that energy converts into new quark-antiquark pairs before separation succeeds. Reality resists fragmentation. And because of confinement, enormous energy remains trapped permanently inside protons and neutrons. Matter gains mass through imprisoned energy. This idea becomes emotionally difficult because human intuition evolved around stable surfaces, not hidden quantum violence. A stone feels calm and motionless, yet inside every atom, quantum fields fluctuate constantly. Particles exchange gluons continuously. Energy surges through confined spaces invisibly. Stillness becomes illusion. Even ordinary matter is dynamic underneath. And then the Higgs field enters this picture again. Without the Higgs mechanism, quarks themselves would become massless. The detailed balance of quantum chromodynamics changes dramatically. Stable nuclear structures likely fail. The strong interaction alone still generates energy, but the resulting universe behaves profoundly differently. The Higgs field does not create all mass directly. It helps create the conditions, allowing matter itself to stabilize properly. This distinction matters because it reveals how interconnected reality really is. Mass is not produced by one simple mechanism alone. Instead, multiple quantum fields and interactions cooperate to produce the stable universe humans experience daily. The Higgs field gives fundamental particles intrinsic mass. The strong force generates additional mass through confined energy. Electromagnetic interactions organize atoms into chemistry. Quantum mechanics stabilizes electron orbitals. Reality emerges from overlapping invisible systems, interacting simultaneously. And all of it happens beneath ordinary perception continuously. You never feel gluon fields inside your body. You never sense the Higgs field surrounding you. You never notice quantum fluctuations in the vacuum. Yet your existence depends on them completely. This is one reason modern physics often feels emotionally surreal. The deeper scientists investigate matter, the less material it becomes in the ordinary sense. Solid objects dissolve into probability fields, energy interactions, geometry, and hidden quantum structure underneath. Even the distinction between matter and energy begins collapsing. Particles emerge from fields. Fields contain energy. Energy produces mass. Mass shapes space-time. Space-time influences fields. Reality becomes circular and relational, rather than built from isolated things. And perhaps nowhere is this more astonishing than in the early universe itself. Shortly after the Big Bang, temperatures were so extreme that protons and neutrons could not exist stably. Quarks moved freely inside an ultra-hot plasma filling the cosmos. The Higgs field had not yet settled fully into its present state. Matter as humans know it had not formed yet. The universe looked alien beyond imagination. Then expansion cooled reality gradually. The Higgs field condensed into the vacuum. Quarks became confined inside protons and neutrons. Atoms eventually formed. Stars ignited. Galaxies emerged. Complexity slowly crystallized out of quantum chaos, and all of it depended on invisible fields hidden beneath empty space itself. The universe humans experience daily is not built atop stable, solid foundations. It is built atop hidden interactions between quantum fields stretching throughout all of existence. And perhaps this leads toward one of the strangest realizations of all. When you touch a table, you are not truly touching solid matter the way human intuition imagines. Electromagnetic forces between atoms prevent overlap. Quantum fields interact. Energy patterns resist compression. Reality feels solid because invisible fields resist one another. Matter itself becomes relationship. And somewhere beneath every atom in your body tonight, gluon fields continue surging silently inside nuclei, while the Higgs field stretches invisibly through all of space, quietly shaping the existence of mass itself. For decades, the Higgs field existed only as mathematics. Elegant mathematics, powerful mathematics, but still only theory. And this created a strange tension in physics, because the standard model, the framework describing fundamental particles and forces, worked almost perfectly everywhere scientists tested it. Experiments repeatedly confirmed its predictions with astonishing precision. Electrons behaved exactly as expected. Quarks behaved correctly. The weak force matched calculations. Particle collisions produced outcomes. The equations predicted down to extraordinary decimal accuracy. The theory was unbelievably successful. Yet, something enormous remained missing. Because according to the equations, the Higgs field should produce a corresponding particle, an excitation of the field itself. Just as photons arise from the electromagnetic field, the Higgs field should produce its own quantum particle, the Higgs boson. And without detecting it experimentally, physicists could never be fully certain the mechanism giving particles mass was actually real. This uncertainty mattered deeply, because science does not operate on beauty alone. Nature itself must ultimately decide whether equations describe reality correctly. No matter how elegant a theory appears mathematically, experiments remain the final authority. And finding the Higgs boson became one of the greatest scientific challenges humanity ever attempted. The problem was energy. The Higgs boson is extremely unstable. If produced, it decays almost instantly into other particles. Scientists could never simply observe one sitting still inside a detector. Instead, they needed to recreate conditions energetic enough for Higgs bosons to appear briefly during particle collisions, and then infer their existence from decay signatures afterward. This required machines unlike anything humans had ever built before. Particle accelerators already existed throughout the 20th century, gradually growing larger and more powerful as physics advanced. Electrons collided with positrons. Protons smashed together at enormous speeds. New particles emerged from the debris, revealing deeper layers of matter. Every generation of accelerators uncovered something unexpected. Quarks, neutrinos, new bosons, exotic resonances. The deeper humanity pushed into the quantum world, the stranger reality became. But the Higgs boson required something unprecedented. To create one reliably, scientists needed collision energies approaching conditions existing fractions of a second after the Big Bang itself. And so humanity built the Large Hadron Collider. Buried beneath the border between France and Switzerland, the LHC became the most powerful particle accelerator ever constructed. A gigantic underground ring 27 kilometers in circumference accelerated protons to velocities incredibly close to the speed of light. Superconducting magnets cooled colder than outer space guided the particles around the ring, while enormous detectors waited at collision points to record what happened next. The scale of the project was staggering. Thousands of scientists collaborated across countries and continents. Detectors larger than buildings tracked showers of particles emerging from collisions. Data flooded into computers continuously, at rates almost impossible to comprehend. Tiny fractions of seconds after each impact, entirely new particles briefly appeared before decaying again. And inside this chaos, physicists searched for the Higgs. The challenge resembled trying to identify a single ripple inside an ocean during a hurricane. Most collisions produced ordinary known particle interactions. Higgs bosons, if they appeared at all, emerged extremely rarely. Worse still, they vanished almost instantly into other particles. Scientists could not observe the Higgs boson directly, in any simple sense. Instead, they reconstructed decay pathways statistically. Patterns mattered. If enough collisions produced slightly more events matching certain predicted decay combinations than ordinary physics alone allowed, then the Higgs boson might finally reveal itself. Years passed. Collision energies increased. Data accumulated. And then something began appearing. A small statistical excess emerged near a particular energy range, around 125 giga-electron-volts. At first, the evidence remained uncertain. Physicists are extraordinarily cautious because random fluctuations can imitate meaningful signals temporarily. Statistical significance matters deeply in particle physics. Extraordinary claims require overwhelming evidence. But as more data arrived, the signal strengthened. On the 4th of July 2012, scientists at CERN announced the discovery of a new particle consistent with the Higgs boson. Humanity had found evidence for the field hidden inside empty space itself. The announcement became one of the most important scientific moments of the century. And emotionally, the discovery carried extraordinary meaning, because it confirmed something profound about the nature of reality. Mass is not merely built into matter automatically. The vacuum itself helps create it. Invisible quantum structure stretching throughout the universe shapes the existence of every atom, every planet, every star, and every living organism. Reality depends on hidden fields humans never directly perceive. And perhaps the strangest part is that the Higgs boson itself was never the ultimate goal emotionally. The true discovery was the field. The boson merely confirmed the field existed physically. This distinction matters because particles in modern physics increasingly look less fundamental than the underlying fields producing them. The Higgs boson is simply a temporary ripple inside the Higgs field. Photons are ripples in the electromagnetic field. Electrons are ripples in the electron field. Reality keeps shifting away from solid objects toward invisible structure underneath, and the Higgs discovery reinforced this transformation dramatically. The universe no longer looked like matter floating through emptiness. Instead, matter emerged from interactions between hidden quantum fields woven throughout space-time itself. This idea becomes emotionally overwhelming when applied universally. Every human being is immersed inside the Higgs field continuously. Every star burning in distant galaxies interacts with it. Every atom formed after the Big Bang depended on it. The field permeates the observable universe almost perfectly uniformly. It stretches across billions of light years, silently shaping existence itself. And without it, none of the visible structures humans associate with reality could stabilize properly. No chemistry, no planets, no biology, no observers wondering about the universe. In a strange sense, the Higgs field helped make complexity possible. And yet, even after discovering the Higgs boson, physics remained incomplete. The Standard Model describes known particles and forces extraordinary. Could other Higgs-like fields exist? Why does the universe choose this particular vacuum state rather than another? Humanity still does not know, and perhaps that uncertainty matters. Because once again, the universe refuses to become simple even after one of the greatest scientific discoveries in history. Every answer reveals deeper hidden layers underneath. The Higgs boson completed the Standard Model experimentally, but it did not complete humanity's understanding of reality itself. Instead, it revealed even more clearly that existence emerges from invisible structures hidden beneath ordinary perception. And somewhere tonight, throughout the darkness between galaxies, the Higgs field continues stretching silently through all of space-time, quietly shaping the existence of matter itself, while human beings live their lives almost entirely unaware that every atom in their bodies depends on its invisible presence. At first glance, the Higgs field sounds almost simple. An invisible field fills the universe. Particles interact with it. Mass emerges. But the deeper physicists investigated this idea, the stranger it became. Because once the Higgs field settled into the vacuum shortly after the Big Bang, it did not merely affect particles individually. It reshaped the entire structure of reality itself. The universe humans inhabit today exists partly because empty space chose a particular state billions of years ago. And this realization is deeply unsettling, because it means the vacuum is not neutral. Empty space itself contains properties determining how reality behaves. This idea would have sounded absurd to earlier generations of scientists. For centuries, the vacuum was imagined as simple absence, a passive emptiness where matter moved around. But modern physics transformed the vacuum into something active, dynamic, and strangely powerful. Quantum fields permeate it. Fluctuations ripple through it. Energy exists within it. And the Higgs field gives the vacuum a hidden structure, influencing every particle in existence. The vacuum shapes the universe, and perhaps nowhere does this become stranger than in the question of stability. According to measurements of the Higgs boson and top quark masses, some physicists suspect the universe may sit near the edge of vacuum instability. This does not mean reality is about to collapse suddenly tomorrow. The universe appears extraordinarily stable on timescales vastly longer than human history. But mathematically, the current vacuum state might not represent the absolute lowest energy state possible. In other words, the vacuum humans inhabit could theoretically be metastable, like a ball resting in a shallow valley rather than the deepest valley available. And if that is true, then somewhere within the laws of physics exists the possibility, however remote, that the Higgs field could someday transition into a lower energy state. This idea is called vacuum decay. And emotionally, it is one of the most terrifying possibilities modern physics has ever uncovered. Because if vacuum decay occurred, the consequences would not resemble an explosion or ordinary disaster. Instead, reality itself would change. A bubble of lower energy vacuum would form and expand outward at nearly the speed of light. Inside the bubble, the fundamental constants and interactions governing matter might become different. Atoms could fail, chemistry could collapse, particles might acquire different masses. The laws supporting stars, planets, and biology could vanish entirely. And there would be no warning. Because the bubble wall would move essentially at light speed, observers could never see it approaching. One moment the universe behaves normally. The next, the underlying structure of reality itself changes permanently. Fortunately, if vacuum decay is possible, calculations suggest the current vacuum likely remains stable for unimaginably long timescales, perhaps vastly longer than the lifetime of stars themselves. Still, the possibility reveals something profound about the Higgs field. The vacuum is not merely empty background beneath existence. It determines the structure of existence itself, and this transforms how physicists think about the universe fundamentally. Because the properties of particles are no longer fixed independently from space. Instead, particles acquire behavior through interaction with the vacuum surrounding them. The universe resembles a medium shaping matter continuously, rather than a passive emptiness containing independent objects. Reality becomes contextual. And perhaps this is why modern physics increasingly blurs the distinction between space and substance. The Higgs field exists everywhere simultaneously. Remove all particles from a region, and the field remains. Even perfect emptiness still contains the Higgs field quietly sitting in its vacuum state. The vacuum is full of hidden structure, and this hidden structure may connect to even deeper mysteries. One of the biggest unresolved problems in physics involves something called the hierarchy problem. Compared to the enormous energies associated with gravity and the Planck scale, the Higgs boson mass appears strangely small and delicately balanced. Quantum corrections should naturally push its mass toward vastly larger values unless some unknown mechanism stabilizes it. This bothers physicists deeply because nature usually avoids extreme fine-tuning without reason. Why is the Higgs field value exactly what it is? Why does the universe permit stable matter rather than collapsing into chaos? Why do particles possess masses compatible with stars, chemistry, and life? Humanity still does not know. Some theories propose supersymmetry, where hidden partner particles stabilize the Higgs mass through quantum cancellations. Others suggest entirely new sectors of physics beyond the standard model. Some explore multiverse ideas, where different regions of reality possess different vacuum states and physical constants. And suddenly, the Higgs field stops looking like the end of a scientific story. It becomes the doorway into deeper mysteries underneath. Because once again, reality refuses to become simple. Every layer of understanding reveals another hidden layer beneath it. Atoms contained nuclei. Nuclei contained quarks. Particles emerged from fields. Fields shaped the vacuum. Now the vacuum itself may connect to deeper unknown structure still hidden from science. And perhaps this endless depth is one of the strangest things about existence. Human beings evolved expecting solid objects moving through empty space. Instead, the universe appears built from invisible fields, fluctuating quantum interactions, hidden symmetries, and vacuum states shaping reality itself from underneath perception. The world humans directly experience may only be the surface layer of something far stranger. And emotionally, there is something almost haunting about that realization. Because the Higgs field surrounds you constantly without ever revealing itself directly. Every breath you take, every movement you make, every atom in your body depends partly on interaction with this invisible field permeating all of space-time. The field existed long before Earth formed. It may continue existing long after the last stars die. Human beings live immersed inside hidden cosmic structure, continuously, without awareness. And maybe this points toward a deeper truth about science itself. The universe was never obligated to be understandable through ordinary intuition. Evolution prepared the human brain for survival on African plains, not for understanding quantum fields or vacuum structure. Yet, through mathematics and experiment, humanity slowly uncovered invisible layers beneath reality itself. That achievement is extraordinary. A small species, living briefly on a rocky planet, discovered the field hidden inside empty space that helps give matter its mass. And still, the mystery continues, because somewhere tonight, throughout the darkness between galaxies, the Higgs field stretches silently across the cosmos, shaping particles, stabilizing matter, and quietly determining the structure of reality itself, while deeper layers of physics still remain hidden underneath, waiting for future minds to uncover them. There is a deeply unsettling possibility hidden inside modern physics. The universe almost may not have worked at all, not in the dramatic sense of exploding incorrectly or collapsing instantly, but in a quieter and perhaps stranger way. The laws of physics could have produced a cosmos where stars never formed properly, atoms never stabilized, chemistry never emerged, and life never appeared anywhere. A universe filled mostly with radiation and emptiness. A silent universe. And the Higgs field sits disturbingly close to the center of this mystery. Because once physicists understood how the Higgs mechanism gives particles mass, another realization followed naturally. The exact strength of the Higgs field matters enormously. Tiny changes to its value could radically alter the structure of reality itself. If the Higgs field were slightly different, electrons might become too heavy or too light. Quarks could fail to form stable protons. Nuclear fusion inside stars might behave differently. Chemistry could collapse. Complex molecules might never emerge. Reality appears delicately balanced. And emotionally, this is difficult to process, because human beings instinctively assume the universe had to exist roughly the way it does. Stars, planets, oceans, and biology feel natural because they are familiar, but physics increasingly suggests the opposite. The universe humans inhabit may represent only one narrow possibility among many, and most alternatives look lifeless. This realization became especially disturbing after physicists began exploring how the constants of nature interact with one another. The masses of particles, the strengths of forces, the structure of quantum fields, all of these values influence the stability of matter itself. If electromagnetism were slightly stronger, stars burn differently. If the strong force changed slightly, nuclei destabilize. If the Higgs field changed, particles acquire different masses entirely. The universe appears balanced on invisible relationships between quantum fields and forces, and nobody fully understands why. This mystery becomes even stranger when thinking about the early universe. Shortly after the Big Bang, reality looked almost unimaginably hostile compared to the modern cosmos. Temperatures exceeded anything humans can truly emotionally picture. Matter existed as an ultra-hot plasma. Particles collided continuously with enormous energy. Ordinary atoms could not survive. Even protons and neutrons had not fully stabilized yet. And then, during this violent early era, the Higgs field changed state. The vacuum itself transformed. This moment may have determined the future structure of the entire universe. Before symmetry breaking, particles remained effectively massless within electro-weak interactions. Then the Higgs field settled into its non-zero vacuum value, and suddenly the laws governing matter shifted permanently. Particles acquired mass, forces separated. The universe entered a new phase of existence, and everything afterward depended on that transition occurring correctly. Stars, galaxies, chemistry, biology, conscious observers. All of it emerged downstream from invisible quantum structure condensing into the vacuum billions of years ago. The universe humans know was not inevitable. It emerged from specific physical conditions unfolding with astonishing precision. And this realization quietly changes the emotional meaning of existence itself. Because human beings stop looking like isolated accidents floating through meaningless emptiness. Instead, life becomes deeply connected to the underlying structure of reality itself. Your existence depends on quantum fields, particle masses, force strengths, vacuum states, and cosmic evolution stretching back to the earliest moments after the Big Bang. You are tied to the architecture of the universe more intimately than human intuition naturally realizes. And then there is the anthropic principle. This idea remains controversial philosophically, but emotionally fascinating. The anthropic principle suggests humans observe a universe compatible with life precisely because only such universes permit observers to exist in the first place. In other words, perhaps many possible vacuum states or physical constants could exist, but conscious beings naturally appear only inside the rare universes where the laws allow stable complexity. Some physicists connect this idea to multiverse theories emerging from inflationary cosmology and string theory. Different regions of reality might possess different vacuum states, different particle masses, different physical constants. Most universes could remain sterile forever. No stars, no chemistry, no biology, only radiation and darkness. But in rare regions where the Higgs field and other constants settle into suitable values, structure emerges. Galaxies form, stars ignite, planets cool, life evolves. And eventually, conscious beings begin wondering why the universe works at all. Now, whether the multiverse truly exists remains uncertain. Physicists debate it intensely. But regardless of the ultimate answer, the Higgs field revealed something profound. The properties of reality are not emotionally obvious. Mass itself depends on hidden quantum structure. The universe humans inhabit depends on invisible fields permeating empty space. And perhaps the strangest part is how close reality may sit to instability. The Higgs field value measured experimentally appears intriguingly near the boundary between long-term stability and metastability. Some physicists find this deeply suggestive. Maybe it is coincidence. Maybe deeper physics explains it eventually. But once again, the universe looks delicately balanced rather than inevitable. Reality feels less like a rigid machine and more like a dynamic system balanced atop hidden quantum relationships underneath existence. And this changes how the night sky feels emotionally. Stars stop seeming permanent and obvious. Instead, they become temporary structures allowed by invisible fields and finely balanced laws. The universe itself begins resembling an improbable emergence from deeper mathematical structure beneath the vacuum. Matter exists because quantum fields interact correctly. Atoms exist because particles possess suitable masses. Planets exist because stars forge heavy elements. Life exists because chemistry stabilizes. Everything connects backward toward invisible structure hidden beneath reality itself. And maybe that is one of the most beautiful consequences of modern physics. The deeper humanity investigates existence, the more interconnected everything becomes. Human beings are not separate from the cosmos observing it externally. You are part of the same quantum fields, forces, and vacuum structures shaping stars and galaxies. The atoms in your body gained mass through the same Higgs field permeating all of space-time. The particles composing your brain emerged from processes beginning shortly after the Big Bang itself. You are woven into the architecture of reality, and somewhere tonight, beyond the galaxies, the Higgs field continues stretching invisibly across the universe, quietly holding matter together, while the deeper reasons for its existence remain hidden inside mysteries physics still has not solved. At some point, after following the Higgs field through quantum physics, through the early universe, through invisible fields hidden inside empty space itself, a strange realization begins emerging quietly underneath everything else. Reality may not be built from things at all. Human intuition insists that objects come first. A planet exists, a chair exists, a human body exists. Matter appears fundamental, while space merely separates objects from one another. But modern physics keeps dismantling this picture layer by layer. Atoms dissolve into particles. Particles dissolve into fields. Fields shape the vacuum. The vacuum determines particle masses. And now physicists increasingly suspect that even space-time itself may emerge from deeper hidden structure underneath. Reality becomes less material the deeper science looks. And perhaps nowhere is this transformation more obvious than with the Higgs field itself. Because the Higgs field is deeply strange emotionally, it exists everywhere simultaneously, Yet humans cannot see or feel it directly. It shapes every atom in existence, yet ordinary perception remains completely unaware of it. It helped make stars, chemistry, planets, and biology possible. Yet most people live their entire lives without realizing an invisible field permeates all of space-time continuously. The universe becomes hidden beneath appearances. And once this realization settles into the mind, ordinary reality starts feeling almost dreamlike. Solid matter no longer appears fundamentally solid. A table becomes organized energy, and quantum fields stabilize through invisible interactions. Your body becomes a temporary structure, emerging from particles whose masses depend on hidden vacuum properties. Even empty space stops looking empty once you understand that invisible fields continue stretching through it endlessly. The visible universe becomes the surface layer of something deeper, and modern theoretical physics keeps pushing this idea further. Because even the Higgs field may not be fundamental ultimately, some theories suggest the Higgs boson itself could be composite, built from smaller underlying structures still undiscovered. Others propose extra Higgs-like fields, hidden beyond the standard model. Supersymmetry predicts entire families of undiscovered particles interacting with known fields. String theory replaces particles with vibrating strings beneath quantum fields entirely. Every attempt to understand reality more deeply reveals additional layers underneath. The universe refuses to become simple. And emotionally, this is astonishing, because human beings evolved expecting certainty from the physical world. The ground feels stable, matter feels permanent, reality appears obvious. Yet science keeps revealing that beneath appearances lies hidden complexity almost beyond imagination. Invisible fields permeate the cosmos. Particles emerge from fluctuations. Mass arises through interaction with the vacuum. Space-time itself may emerge from deeper quantum relationships. The universe looks increasingly less like a machine built from objects and more like an interconnected web of hidden structure. And perhaps the strangest part is that mathematics continues describing this hidden structure with extraordinary accuracy. Equations written by human minds predicted the Higgs boson decades before experiments confirmed it. The mathematics revealed that particles required interaction with an invisible field long before humanity possessed machines powerful enough to detect evidence for that field directly. Why should mathematics work this well? This question becomes haunting the deeper physics goes. Human beings evolved on a small, rocky planet under ordinary conditions. Nothing about evolution prepared the brain to understand quantum fields or space-time curvature. Yet somehow abstract equations developed inside human thought continue mapping onto reality with astonishing precision. Some physicists believe mathematics merely describes the universe. Others suspect reality itself may fundamentally possess mathematical structure underneath physical appearances. And once again, the Higgs field sits near the center of this mystery. Because the field reveals that invisible symmetry principles shape the universe profoundly. The masses of particles emerge from deeper mathematical relationships hidden inside quantum fields. Reality behaves less like arbitrary chaos and more like structured geometry unfolding through invisible rules. The cosmos becomes intelligible in ways that feel almost uncanny. And then there is one final unsettling realization. The Higgs field does not merely exist inside the universe. It helps define what the universe is capable of becoming. Without the Higgs field, no stable atoms. Without stable atoms, no chemistry. Without chemistry, no biology. Without biology, no conscious observers. Which means conscious life itself depends partly on hidden quantum structure woven into the vacuum of space. You exist because the vacuum possesses the properties it does. And perhaps that is one of the deepest ideas modern physics has uncovered. Human beings are not separate from the universe observing it externally. You are an expression of the same fields, forces, and structures shaping stars and galaxies. The particles inside your body gained mass through the same invisible Higgs field stretching across the cosmos. The atoms composing your brain emerged from processes beginning shortly after the Big Bang itself. You are woven directly into the architecture of reality. And maybe that is why physics often feels strangely philosophical at its deepest levels. Because eventually, the questions stop being merely about particles and forces. They become questions about existence itself. Why does the vacuum possess hidden structure? Why do quantum fields exist at all? Why does the universe obey elegant mathematical laws? Why does anything exist instead of nothing? Humanity still does not know. And perhaps that uncertainty matters more than people realize. Because it means reality still contains hidden territory waiting to be discovered. Science is not finished. The universe has not become exhausted intellectually. Beneath every solved mystery, deeper mysteries remain hidden underneath. The Higgs field solved one profound question about mass, but in doing so, it revealed an even stranger universe than humanity imagined before. A universe built from invisible fields. A universe where matter emerges from interaction. A universe where empty space contains hidden structure. A universe where reality itself may arise from layers still hidden beneath human understanding. And somewhere tonight, throughout the darkness between galaxies, the Higgs field continues stretching silently across all of space-time, quietly giving mass to matter, while deeper unseen layers of reality remain waiting in the dark beyond it. And so tonight, after following the Higgs field through the vacuum of space, through the early universe, through quantum fields hidden beneath reality itself, we arrive at one final realization. Mass is not as simple as it appears. The universe humans experience every day feels solid, stable, and obvious. Objects resist motion, matter possesses weight, stars collapse under gravity, planets orbit through space. Everything about reality seems built from physical substance. But modern physics revealed something far stranger. Matter gains mass through interaction with invisible quantum structure permeating all of existence. An unseen field stretches silently across the cosmos, through galaxies, through planets, through your own body, shaping the behavior of particles every moment of your life. Without it, atoms would not stabilize, chemistry would collapse, stars would behave differently, human beings would never exist at all. The vacuum itself helped make reality possible. And perhaps the strangest part is that this hidden structure surrounds you constantly without ever revealing itself directly. Every atom in your body depends partly on interaction with the Higgs field. Every piece of matter you have ever touched owes its stability to invisible quantum relationships hidden beneath ordinary perception. Reality is deeper than human intuition. The universe only appears simple from a distance. But the closer humanity looks, the stranger existence becomes. Particles dissolve into fields. Fields shape the vacuum. The vacuum shapes matter itself. And beneath all of it, deeper hidden layers may still remain undiscovered. If you enjoyed this calm exploration into the Higgs field, quantum physics, mass, and the hidden structure beneath reality, subscribe to Science Sleep Theory for more deep journeys into the strangest ideas ever uncovered by science. And for now, as invisible quantum fields continue stretching silently throughout the darkness between galaxies, let your thoughts drift slowly outward into the hidden architecture beneath the universe itself. Good night.